All right, hello Algebra. So we are going to start looking at Standard C, okay? And Standard C will include some stuff from Chapter 2. So today we're looking at 2.6 ratios and proportions. Going to start with some definitions. So ratio and proportion, these are probably words that you've heard before, but I'm going to give you some solid mathematical definitions and then some examples as well. So a ratio is a comparison of two numbers by division. All right, and there are three ways that you can write a ratio. All right, but first let's talk about like an example, and then I'll write it in those three ways. So an example would be, so if there are 30 students in a classroom and there are 3 teachers in the classroom, the ratio of students to teachers would be 30 to 3, okay? So we have 30 students, I should have written this down, 30 students and 3 teachers in the classroom. All right, so notice how I wrote the ratio here. Okay, so that's one way we can write the ratio is with a colon. Another way we can write the ratio is to write out the 2, TO, 30 to 3. And then the last way is you write it as a fraction or division. Okay, and that would make sense because we're comparing two numbers by division. Whenever you read a ratio, though, you read it as it's written here, 30 to 3. So I read this 30 to 3. Right? So that's a ratio. Now, proportion. People tend to use these interchangeably. Not the exact same thing, though. So proportion is an equation that states, so it's stating that two ratios are equal. All right, so if you think about this ratio up here, we have 30 students to 3 teachers, so that ratio is 30 over 3. If we wanted to write a ratio that is equivalent to that, what we would do is we can reduce this fraction, 30 over 3. All right, so let's divide by 3 because both are divisible by 3 to get this equivalent ratio, this equivalent fraction. 3 divided by 3 is 1. 30 divided by 3 is 10. All right, so now we have two ratios, 30 to 3 and 10 to 1. The units stay the same. So this was 30 students to 3 teachers. All right, now we have 10 students to 1 teacher. We just simplified it, so now we know for every teacher there are 10 students. So that's really where proportions come in handy, is simplifying your ratio to its simplest form. All right, so this right here, 30 over 3 equals 10 over 1. Two ratios are equal. This whole thing right here is a proportion. Not just one of the ratios, not just the other ratio, the whole thing is a proportion. All right, so you might be given two ratios that don't actually create a proportion. Right? Sorry, I gotta move my computer really quickly. All right, so there are two ways to determine if two ratios create a proportion, or how I have it written here, two ways to determine proportionality. One of the ways is you put each ratio into its simplest form. So what you do is you reduce each ratio. So this first example, we have 15 to 20 and 5 to 10. We reduce both of them, and if those reduced ratios are equal, then these ratios are equal and we form a proportion. So let's reduce 15 over 20. Well, ends in 5, ends in 0, so they can both be divided by 5. 15 divided by 5 is 3, and 20 divided by 5 is 4. I can't reduce that anymore, so that is one of our reduced ratios. And then now the 5 over 10, those can both be divided by 5. 5 divided by 5 is 1, 10 divided by 5 is 2. There is my other reduced ratio. Now, does this form a proportion? Is 3/4 equal to 1/2? No, right? We can write 1/2 as 2/4. 3/4 is not equal to 2/4, so no, this is not a proportion. All right, next one. I encourage you to pause here, reduce both of these, and see if they're equal. Okay, so give it a shot. Now we will go through it. So I will reduce 7 over 21. Those are both divisible by 7. And I have 1 over 3. And then I have 4 over 12. I can divide both of those by 4, and I get 1 over 3. Well, 1 over 3 equals 1 over 3. So yes, it is a proportion. These two create a proportion. So I can put equal signs in between those. Where up here, I couldn't, right? If I had equal signs, I'd have to do the non-equals there. All right, so that is one way to decide whether you create a proportion with two different ratios. You simplify them, and if those simplified fractions are equal, you have a proportion. Another way is to use cross products. I'm not sure if you guys have ever seen cross products. So if we have two ratios, A over B, okay, and let's say it's equals C over D, okay, this will be true if the cross products are equal. So what a cross product is you multiply diagonally, right? Product means multiply. So we're going to multiply cross. So A times D, so A times D needs to equal C times B, or B times C, however order you want to write it, okay? So this is true if this is true. So to determine whether 8 over 10 equals 3 over 4, we need to do the cross products. So 8 times 4, so I'll write that here, 8 times 4 must equal 3 times 10. All right? If 8 times 4 equals 3 times 10, then 8 to 10 equals 3 to 4. All right? Then this would be a proportion. Well, 8 times 4 is 32. 3 times 10 is 30. All right, 32 does not equal 30, so that's not equal. So that means this isn't equal, and that means this is not equal. All right, if these aren't equal, then they do not form a proportion, right? It's not two ratios equal to each other. All right, so now that you've seen cross products, pause here and try this one on your own. All right, so need to see if these two ratios are equal to each other. Do we create a proportion? So I'm going to look at the cross product. So I'm going to do 6 times 13 and see if that equals 3 times 26. Well, let's see. 6 times 13, if I put that in my calculator, I think it's 78. All right, 3 times 26, that is also 78, and those are equal. So that means this proportion, this is a proportion, right? Those ratios are equal to each other. So it is a proportion. All right, so now that we've talked about proportions and what they are, we are going to look at solving proportions. All right, so notice right here, it's already equal. So we're saying that this creates a proportion, but we have this variable up here that we don't know the value of. We need to figure out what value of x will make this true. So like before we were solving equations, because we had x's in there, we had to find a value of x. Now we're solving proportions. We have proportions, we have x's in there, find the value of x that'll make it true. So to do this, what we're going to use are cross products. Right, because we can't really simplify x over 10, right? So using cross products will really help us. So what we're going to do is do our cross products. So first cross product is x times 5, or 5x, equals, then we do 10 times 3. All right, so I really have 5x equals 10 times 3 is 30. And now I need to solve for x. All right, so I need to undo this multiplication, right? It's 5 times x. To undo multiplication, you use division, and then you divide on both sides. You do that exact same thing to both sides. So to undo the multiplication of 5, I divide by 5 so that those will cancel. Divide by 5 over here as well. So I have x equals 30 divided by 5 is 6. And that would be the solution. Not too bad, right? Let's do another one. Okay, see this one is x times 2, so it'll be a little bit different. But we're still going to start with the cross product, so it's not x times 2, it's x minus 2. So we do x minus 2 times 7. So x minus 2 times 7 equals the other cross product, equals 14 times 2. All right, so I'm going to do 2 steps in one here. I'm going to simplify both sides. So I have 14 times 2 over here, which is 28. And then over here, I have x minus 2 times 7. I need to distribute. So I'm going to do 7 times the positive x, which is 7x. And then I will do 7 times, this is a minus 2, guys. So 7 times negative 2 is negative 14. All right, now this is something that we see all the time. PEMDAS in reverse order. We are undoing the operation, so we need to undo PEMDAS. So to get rid of this subtraction of 14, I will add 14, and I do it to both sides. Those cancel, and I have 7x left. And then I do 28 plus 14, which is 42. Yeah, 42. Okay. Now I have 7x equals 42. Undo the multiplication of 7 by dividing by 7, and I get x equals 6. And that would be my answer. Not too bad, huh? Let's look at this third one. All right, so I encourage you to pause here and attempt this one on your own, okay? All right, let's do it. So I'm going to do cross products, so I'm going to do them across here. So I'll do 2 times 3x minus 1, and then that's equal to 4 times 1, which is just 4. Going to distribute, 2 times 3x is 6x, 2 times a minus 1, so minus 2, equals 4. All right, PEMDAS in reverse order. I'm going to get rid of this subtraction first by adding. I'll do it to both sides. Those will cancel, and I'll have 6x equals 4 plus 2 is 6. Then I need to undo this multiplication of 6. Cancel there. I'll be left with x equals 6 divided by 6 is 1. So x equals 1. And that is the answer. So just like with equations, you can always double check. And as you're starting to get used to these, I encourage you to double check your answers. by taking that value of x, so these values of x here, and plugging those back into the proportions to make sure we end up with two equal fractions. Okay? Okay, so we have a couple more definitions that we're going to end with today. All right, so the first definition is rate. Okay, so that's where the word ratio comes from, is ratio is a rate, or a rate is a ratio, either or. So a rate is, oh, come on, pen, the ratio of two measurements having different units of measure. So you've heard rates many times, right? So an example would be, so the rate that my car uses gas. Okay, so my car has a 10-gallon tank, and I can get about 300 miles out of that 10 gallons. So my rate of gas use is for every 300 miles. I do every 300 miles per, right? So when you see this line, or you could write it as a fraction bar like that, say per. I know it sounds kind of weird, but division, okay, one of the words for division is per. 30 miles per 10 gallons. You might not be used to thinking about miles per gallons, where this is not 1 gallon, right? You're like, okay, well, how many miles do you get to a single gallon? What you can do is reduce this to figure out how many miles per gallon I get. And I get about 30 miles to 1 gallon. So you could write this as 30 miles per gallon, right? This is called a unit rate. So a unit rate is a rate that tells how many of one item is being compared to one of the other. So with my miles per gallon, it's telling me how much of one item, so how many miles, is being compared to one item of the other, so 1 gallon. Okay, so you might think of this as miles per gallon. You can also think of miles per hour, right? So if you do 60 miles per hour, you are going 60 miles in 1 hour. All right, so rate and unit rate, kind of similar, I guess you'd say. The unit rate is just taking a rate and simplifying it so that you have a 1 in one, either the top or the bottom of your ratio, so that you're comparing it to one item for one of the measurements. Last one is a scale. And so what a scale is, you might have heard a scale before, like a scale model. So a scale is used to make a scale model of something that could either be too large or too small. So maybe like a cell or an atom. So it's too large or too small to be convenient at actual size. So things that would be maybe too small, that would be like a cell, atom, maybe a microchip, like a really tiny chip, like a macro chip. I don't know the words too well for that. Something that could be too large, that could be like a house. Okay, so you'd use, the scale would be on a blueprint, that'd be the scale model. A map, right? If you think about a state, okay, if you think about a map of Wisconsin, you will have a scale on there that'll tell you how many inches equals how many miles. So it could be like, oh, if you measure 1 inch on the map in real life, that would be 20 miles, right? So when you have a scale, say you're like, okay, I know it is, let's do like a quick example over here. 1 inch per 20 miles on the map of Wisconsin. These two places are 200 miles apart. How many inches on the map would that be? How far should I look? Or maybe we don't know how many miles apart they are, but oh, on the map they're 3 inches apart. So how many miles apart are they? This one's more likely that you are like looking at the map and you can measure with a ruler how far away a town is from River Falls, and then use that number of inches to figure out how many miles that is. All right, so that's it for today. These last definitions, these will come in helpful tomorrow. We'll be doing 2.6b, which will be a bunch of applications of cross proportions using cross products, things like that. So I'm going to end the video here, and you guys have this is being really slow. Have a great